Hi, we are going to talk about exponential growth and decay, but we are going to take problems that are a little bit more advanced. And this is the formula we use, where P is the initial amount of something, R is the rate of growth or decay. It's going to be written as a decimal, and T is time. And growth problems R is positive and decay problems R is negative. So population of Oldville was 19,000 in 1996, and then in 2020 it was 8,300, and we need to find the decay rate. So we're looking for R. Let's take all the numbers here. So we have 8,300. By the way, get your calculator ready, you're going to need it. The initial amount was 19,000. Right? E to the power, we don't know R, we know T because it was from 1996 to 2020, that's 24 years, right? So the way we are going to solve it, we are going to divide by 19,000, both sides. Do not do any intermediate calculations, just keep everything until you're ready to plug it all in. Okay, so we need to switch it to a logarithmic form, natural log. And finally, to get R, we are going to need to take ln of 8,300 divided by 19,000 and divide this whole quantity by 24, right? So ln of 8,300 divided by 19,000 divide by 24, and we have negative 0.345. So we're going to write R is negative 0.0345. Depends on the accuracy that we want, right? This is our number. First of all, it's negative as we expected because it's decay. So this would be a rate written as a decimal. If you want to write it as a percent, that would be about 3.5% decay. Yeah, so it all depends on how they want you to write that. Okay? Let's take a look at the next problem. Population of certain bacteria doubles every 7 hours. If there are 400 bacteria now, how many will there be in 30 hours? So there's a couple of things we need to do here. First of all, we start with 400. And we have e to the power RT. The problem here is we have t, but we don't know these two numbers. So we're going to have to find the value of R first. So we know at every 7 hours the population of bacteria is going to double. So we know in 7 hours the population will be 800, right? So if you divide both sides by 400, you are going to get 2 on this side. So 2 equals e to the power 7R. And then ln 2 equals 7R. And R will be ln 2 divided by 7. We should plug it in the calculator. ln 2 divided by 7. And that's going to give us 0.0990. So let's use that. 0.099. Okay, so that's R. And what we're going to need to do now is use that R and plug it back into the formula. So the formula now is going to be A equals 400 e to the power 0.099, I'm sorry, t, and now 30. So A equals 400 e to the power 0.099 times 30. Now we go back to our calculator. and we are going to have approximately 7,797 bacteria. Okay, so this problem does involve two steps because you have to find the rate first, and then you can go ahead and find the actual answer to the question. The population of zombies was 500 8 weeks ago. Today it's 2,700. Find how many zombies will there be 5 weeks from today. Alright, so we know that 8 weeks ago, so that's going to be our starting point. So then we can write A equals 500 e to the power RT, right? We don't know yet anything. We know that today, which is 8 weeks later, is going to be 2,700. So 2,700 equals 500 e to the power R times 8, right? This is very similar to the previous problem, by the way. Except it was easier there with the doubling. So divide both sides by 500. You're going to get 2,700 divided by 500 equals e to the power 8r. Natural log of 2,700 over 500 equals 8r. And then r will be ln of 2,700 over 500 divided by 8. So this will allow us to find the rate. Alright, so we are going to take this ln 2,700 divided by 500 divide by 8, and this will give us 0.211. 0.21079 to 0.211. We're going to round it like this. So r equals 0.211. So we're going to go back to our original problem. We did get a positive value just like we suspected. Okay, this is where you need to be careful because we need to find the population of zombies 5 weeks from today. This number was based on 8 weeks before, so the total value for t we're going to be using is going to be 13 because it's 8 from before plus 5 ahead, right? So then you're going to get 500 e to the power of 0.211 times 13, and back to our calculator. 500 e to the power of 0.211 times 13, and the population will be 7,767 zombies. Okay, and this is how we done. Now in this problem you could have taken, let me just make this quick comment. You could have taken the 2,700 and used 5 weeks, but then you would need to rewrite this. If you want to do it this way, you could have done 2,700 e to the 0.211 t, but then t would be, with t being 5, and that would be okay too. But I always recommend stick to the original problem. Just remember that when it says 5 weeks from today, and this number was 8 weeks before, so the total value is going to be 13. Alright, hope this helps.